Dear ladies and gentlemen, my name is Mykhailo Fryz, and I'd like to represent you the results of our research titled as Property Analysis of Conditional Linear Random Process as a Mathematical Model of Cyclostationary Signal. A conditional linear random process is an important instrument for the problems of mathematical modeling of information signals that can be represented as the sum of large number of stochastically dependent random impulses occurring at Poisson times. The definition of the process as a stochastic integral of random kernel driven by the process with independent increments has been represented on the slide. Many information signals in technical, medical, or economical systems, the mathematical model of which can be represented in the form of a linear or conditional linear random processes, also have the property of cyclicity, which can be caused by various factors, for example, daily, weekly, or seasonal cyclicity of electricity loads, gas or water consumption, the cyclicity of heartbeats in the analysis of electrocardiogram signals, the periodicity of photostimulation in the task of analysis of visually evoked biopotential of the brain, etc. The most general model of such kind of information signals is the cyclostationary random process, whose finite dimensional distribution functions or characteristic functions are periodic with respect to their time arguments. A very important subclass of cyclostationary random processes is the periodically correlated random processes, which have periodic moments functions of the first and second order. The main goal of the research is to justify the conditions for the process to be periodically correlated random process and to describe the class of conditional linear cyclostationary random processes using the characteristic function method. The expectation and covariance function of conditional linear random process are represented on the slide and have been used to prove the conditions for the process to be periodically correlated. It has been proven that if the process with independent increments has periodically correlated increments and the kernel is the bivariate periodically correlated random field, then the expectation and the covariance function of the considered process are periodical with respect to their arguments. Thus, it is conditional linear periodically correlated random process. The m-dimensional characteristic function of conditional linear random process is represented on the slide and has been used to characterize the cyclostationarity property of conditional linear random process. It has been proven that if the process with independent increments has periodic increments and the kernel is bivariate cyclostationary random field, then the characteristic function of conditional linear random process is periodic and the process is cyclostationary. We should note that in many problems of mathematical modeling or information signals in technical, medical or economical applications, the alpha parameter is equal to 1. The structure of identification of information signal mathematical models based on conditional linear cyclostationary random process is represented on the slide. Conditional linear random process model with continuous time, including the cyclostationary case, makes it possible to take into account some important a priori information about the research object and the corresponding stochastic information signal. Thus, the identified model with continuous time becomes adequate for the studied information signal because it is based on its physical nature. We can see that the identification of the appropriate model with discrete time, as well as its informative characteristic detection, the justification of the methods of their statistical estimation, is carried out on the basis of the model with continuous time. The time for conclusions. Thank you very much.